For the first time in 80 years, a star system located 3,000 light years from Earth will be visible to the human eye. It's being called a once-in-a-lifetime event.
The researchers here feel that they're within reach of finding new particles that really make the universe tick. One more heave, they say, and they could make one of the biggest breakthroughs of all time.
For those less scientific, we found at least one person who has an uneasy feeling about the rare alignment and how it'll somehow impact his daily life.
It kind of disrupts things that are normally taking their course.
This enormous underground lab lies hidden away beneath the Swiss-French Alps. The plan is to stretch it even further.
If it goes off between now and September, October, it will be visible, excuse me, everywhere. The nova will get up to about second magnitude. That's about the 50th brightest star in the sky. It's the same as Polaris. If you can see Polaris from New York City, you can see this nova. It'll be easy to see if you get out to a dark place. It will be bright for a few days. It will get up to, as I said, second magnitude and then fade. In a dark place, you can probably see it for a week or two.
Now, the Large Hadron Collider is the world's biggest atom smasher, but as it turns out, it's not big enough. The European Centre for Particle Research, CERN, is unveiling details of a new particle accelerator today, something 3 times larger and twice as deep.
There are so many outstanding questions in fundamental physics today, and in our knowledge of the universe, its structure and its evolution, for which we have no answer. And so we need more powerful instruments to be able to addressing those questions.
Thousands of scientists here are hunting for the tiny particles that are contained in the atoms that make up the world around us. Professor Mitesh Patel has spent his entire professional life searching for them.
I think for me this is really about exploration. To be able to look for something genuinely new. If you're going to go and explore the unknown, then of course you don't know what you're going to find, and you can't guarantee a particular outcome.
This enormous underground lab lies hidden away beneath the Swiss-French Alps. The plan is to stretch it even further.
Nearly every day, I still get that sort of wow as I look at all of it.
This experiment has been going on for more than a decade. It's made some important discoveries, such as a particle called the Higgs boson. This is one of the detectors that discovered the Higgs 12 years ago. It was an incredible scientific achievement. But the LHC was built to do much more than that. It was supposed to discover brand new particles that would change the theory of physics. It hasn't. So in that sense, it's failed. And that's why they need a larger machine. The plan is to build what's called the FCC, the Future Circular Collider, next to the existing accelerator. It'll be at least twice as deep and measure nearly 91 kilometres, that's around 56 miles. Inside, particles will travel much further than they currently do. They're pulsed by an electric field and stronger magnets, which make the particles collide with much greater force and hopefully revealing far more.
But it is more than that, because there are lots of physicians, I know some, they're doing very strange experimentation. There are beings from portals coming in and out. It's physicists from the CERN who told me this.
They've testified to beings coming in and out of portals.
Yes. And they were saying, I mean, I met them at a dinner and there were 2 of them. And both said that, yes, they have, you know, secondhand proof that the people who you know, they're dealing with the boson of Higgs and the subatomic things. So they have apparently in the bottom of the CERN this portal, this door where they are dealing with all the subatomic dimensions. They say there are 17 different dimensions of reality. That's what those physicists say. Some others say there are more dimensions. You know, we know the time, space, you know, the tri-dimensional X, Y, Z in a graphic. But then you have more dimensions, and they are playing with that. They're using that, and we're a group, and they had a being, they did not tell me more, who came that doesn't resemble a human. And then they had another one, and they have a proof because they left a scarf. They left a scarf. And now, when you look at what is going on in the CERN, there is a fight from some of the military agencies, intel. They say that there is a fight on time. They're trying to change time.
You're going to so much effort, digging all these tunnels, spending so much money to smash particles together. And so what's the point?
Scientific exploration. I think it's almost like asking, what's the point of art or music? I think humans have this curiosity of finding what's out there and how does the world around you work? And FCC will help us answer some of those questions.
The countdown is on to a once-in-a-lifetime total eclipse.
The total eclipse takes place on April 8th. At 3:20 p.m., our world will plunge into the eerie, mysterious, wonderful darkness that is totality.
We are, in fact, the only planet that has a moon just the right size to block out the sun.
But also, a few other planets are going to be visible during this time. A few that we're obviously used to seeing. So once that becomes complete totality, becomes darkness, you're going to have Venus, which again, we see a decent amount of times, Jupiter as well.
This is 12P, which is the Pons-Brooks Comet. It comes around every 71 years. Now, the reason that you might be able to see this with the naked eye versus just a telescope is because this comet is known for flare-ups. Oh. It's basically a ball of dirt and ice. So chunks of it routinely break off, and it causes a much brighter flare as it's traveling across the night sky. It actually, because of the way it's shaped right now, it looks like it has devil horns because of the way chunks have broken off, so it's nicknamed the Millennium Falcon. And so if we're lucky enough to get clear skies, the eclipse, and one of those chunks breaking off, you might get to see that comet as well.
With 13 states across the country in the path of totality.
According to NASA, the Great North American Eclipse will stretch from Mexico to Canada and last anywhere from 3.5 to 4 minutes.
When the corona comes out and it goes total, it's like this eyeball looking at you from space, because the sun, instead of being bright, is dark, and it has this white halo around it, and it's like somebody's eye looking down at you.
We're going to be live on TV here on ABC.
4 minutes long, so you'll get the
totality.
The whole spiritual
experience. I'm looking forward to.
If you miss it this time around, the next full solar eclipse in the U.S. from coast to coast won't happen until 2045.
It's a real visceral experience, and the whole anticipation.
The first stage of the new collider won't be fully operational until 2045.
Why is Geneva? Why is Geneva of such significance? Because you've got the World Health Organization, all these meetings in Geneva. You've got CERN in Geneva, Davos, Switzerland. Why is Geneva so significant?
Yeah, I would say Switzerland is very significant in general, but because of our neutrality, there could be many factors. So I could take it at different levels. The geopolitically, the fact that Switzerland is a nice country of peasants, former mercenaries, historically, and they're nice. They look, they're compliant and neutral normally. That's one. But actually, the other one is the banking system. Secret banking system. Still to this day, they can put all the money they want. The immunity is another one. Geopolitically, as the scientists open, you do hypotheses, because that's how you build an open reality, because otherwise you miss the point. It makes sense because they're all here. So it's the World Economic Forum is just opposite the UN. The UN is 10 minutes by car to the CERN. Then you have all the sports association, FIFA, UEFA, also at 10 minutes, half an hour from everything. Yes. So, and then we have the Bank of Settlements in Basel. That's 2.5 hours away by car. But it's all there. Small Switzerland is like the Disneyland of everything they want to do.
Fascinating.
So, yeah, we're close to everything.
Scientists working at the Large Hadron Collider, operated by CERN, have made public the anticipated scheduling of the initial interactions between proton beams on April 8th, following the completion of all machine assessments and adjustments. Subsequently, the substantial experiments carried out by CERN, which entail the collision of proton particles, will be able to recommence their scientific activities for data collection and analysis. Many individuals within the realm of social media have brought attention to the forthcoming total solar eclipse scheduled to occur on Monday, April 8th, 2024. This celestial event is projected to traverse North America, making its passage over countries such as Mexico, the United States, and Canada. The initial phase of the total solar eclipse is set to commence above the South Pacific Ocean. In the event of favorable weather conditions, the point of first contact with totality on the North American continent is predicted to be along Mexico's Pacific coastline, occurring at approximately 11 in the morning. Numerous individuals have commented concerns regarding the potential negative outcomes, suggesting that scientists may be overstepping their bounds by engaging in these experimental pursuits, likening it to playing the role of a deity. In the sphere of speculative science fiction and theoretical physics, the intriguing concept of accessing a portal using the Large Hadron Collider has sparked the interest of numerous enthusiasts. Various hypotheses suggest that the immense energies released during particle collisions within the Large Hadron Collider might potentially lead to the formation of subatomic black holes or wormholes, which are transient phenomena with the potential to act as gateways to alternate dimensions or parallel universes. This idea has captivated the minds of scientists and science fiction aficionados alike, prompting deeper explorations into the realms of possibility and the underlying fabric of the universe, with its infinite mysteries waiting to be unraveled. In a theoretical situation, if particles collide within the Large Hadron Collider, it has the potential to create a microscopic black hole, a space in the fabric of the universe where gravitational pull is immensely intense, preventing any form of light from escaping. These transient black holes, although harmless, present an opportunity to gain crucial insights into the workings of gravity and the foundational forces governing our cosmos. The possibility of generating these tiny black holes in such high-energy collisions opens a window to explore the nature of gravity and its interactions with other fundamental aspects of the universe in a controlled setting. In a different hypothetical situation, the Large Hadron Collider has the potential to unintentionally generate a wormhole, an imagined passage through the fabric of space-time linking far-flung areas of the universe. Wormholes are currently only conjectural constructs, yet their theoretical ability to expedite travel beyond the speed of light or open up avenues for communication over vast cosmic expanses renders them a captivating topic for scientific investigation. The concept of a wormhole, if brought into existence by the collider, could revolutionize our understanding of the universe and the laws of physics. Delving into the idea of initiating a portal through the Large Hadron Collider presents a fascinating prospect that captivates curiosity. However, it triggers substantial ethical dilemmas and considerations of utmost importance. Central to these deliberations is the apprehension surrounding unforeseen repercussions, notably the emergence of perilous occurrences like miniature black holes or erratic wormholes as plausible outcomes. In addition, the activation of a portal holds immense significance for mankind, promising to not only reshape our perception of the universe, but also potentially reconfigure the very essence of existence. Scientists at the Large Hadron Collider are tasked with the responsibility of overseeing scientific advancements and innovations, requiring a meticulous evaluation of the risks and benefits associated with their experiments. They must navigate the delicate balance between progress and caution, recognizing the profound implications that their actions may have on the future trajectory of scientific exploration and on the broader scope of human experience. The Large Hadron Collider is approaching its final year in its current configuration as it gears up for a restart in April. Detailed preparations for this milestone have been meticulously underway since earlier this spring, progressing through a series of meticulous steps and thorough testing procedures. According to an interim report featured on the CERN website, Renda Stierenberg, the head of CERN's accelerator section, highlighted that these preparations are not only on track, but are also proceeding ahead of the planned schedule. At the conclusion of the current measurement season, which is expected to wrap up in either November or December, the forthcoming third long shutdown, known as LS3, is slated to commence. This extended hiatus, spanning several years, is earmarked for the construction of the next-generation particle accelerator, the high-luminosity Large Hadron Collider, designed to generate proton beams 10 times more potent than its predecessor. Over the recent years, CERN has already established a range of cutting-edge facilities dedicated to the project, setting the stage for groundbreaking advancements in particle physics research. The significant experiments conducted at CERN with the participation of NICEF have revealed that the beams are currently observed traversing through their detection systems. This groundbreaking development showcases the successful integration and operation of the detectors within these experiments. In particular, great emphasis was placed on the urgency at the experiment to ensure readiness for the impending return of the beam. The recent installation of a revamped central velo detector, carried out by a collaborative team involving NICEF and various other contributors, marked a pivotal milestone. The replacement became necessary as the prior velo unit, positioned in close proximity to the beam, suffered operational setbacks attributed to an unexpected pressure-related incident. This development underscored the intricate coordination and swift action required in the dynamic environment of the experiment, showcasing the collective efforts to address challenges promptly and uphold the integrity of the research infrastructure. According to a report in Nature in 2015, the Large Hadron Collider, which is the biggest and most potent particle accelerator worldwide, is set to be reactivated in the upcoming days. Despite the global anticipation surrounding this event, there are two individuals who have chosen to keep quiet: Walter Wagner, a former nuclear safety official, and Luis Sancho, a journalist from Spain. They have involvement with the Large Hadron Collider and have decided to come forward with an interesting revelation. Months prior to the planned initiation of the particle collider in 2008, Wagner and Sancho took legal action against the entities responsible for this colossal device. The plaintiffs were the US Department of Energy, Fermi National Accelerator Laboratory, National Science Foundation, and the European Organization for Nuclear Research. It requires immense courage and, perhaps, a touch of irrationality to attempt legal action against any of these institutions, filled with some of the most brilliant minds in the world. This is even more challenging when it happens right before the completion of a $6 billion, 3-decade-long project. In the defense of Wagner and Sancho, they believed they were trying to prevent what seemed like an inevitable and devastating catastrophe. The Large Hadron Collider's potential to generate a miniature black hole that could engulf the Earth was one of their primary concerns. They expressed this worry in their legal action. They said that in due course, the entire Earth would be drawn towards an expanding micro-black hole, resulting in the transformation of our planet into a medium-sized black hole. Consequently, the Moon, satellites, the International Space Station, and other celestial objects would continue to revolve around it. The lawsuit was eventually rejected due to the men's inability to provide evidence of a believable intention to cause harm. Although their concerns were unfounded, considering that the Earth has continued to exist despite the Large Hadron Collider operating for several consecutive years, it is essential to comprehend the safety aspects associated with utilizing the Large Hadron Collider for scientific purposes. Wagner and Sancho presented a lawsuit with 3 concerns. However, it is important to understand why none of these concerns should be a cause for worry. Black holes, which are immensely dense objects, have a mass range that can be as small as 4 to 200 million times the mass of our Sun. Although black holes are typically very large, it is theoretically possible for a small amount of matter, on the scale of tens of micrograms, to be compressed tightly enough to create a black hole. Such a black hole would be considered microscopic in size. Up until now, there have been no instances of the creation or observation of a minuscule black hole, including at the Large Hadron Collider. However, prior to its initial operation in 2008, Wagner and Sancho expressed concerns that the high-speed acceleration and collision of subatomic particles could potentially result in the formation of an extremely dense particle amalgamation capable of giving birth to a black hole. According to the renowned astrophysicist Stephen Hawking, there is an alternative theory that suggests that even if a tiny black hole were to be created within the Large Hadron Collider, it would rapidly break apart and would not pose any danger to the survival of our planet. Black holes, as understood in general relativity, are formed when massive stars collapse under their own gravity, leading to a region of space-time where gravity is so strong that nothing, not even light, can escape. Considering this, the likelihood of creating a black hole under the conditions found in the Large Hadron Collider seems unlikely, as the energies and densities achieved there are far lower than those in stellar processes. However, the black holes in question regarding the Large Hadron Collider are not those of classical general relativity, but rather speculative objects predicted in some theories of quantum gravity, such as string theory. These theories propose additional spatial dimensions beyond the familiar 3, and it is in these extra dimensions that microscopic black holes could theoretically form at the Large Hadron Collider. In these theories, gravity becomes much stronger at small distances than currently observed, allowing for the creation of micro-black holes when particles collide at sufficiently high energies. The energies achievable at the collider, while impressive by human-made standards, are still far below the levels typically associated with black hole production. Yet, if additional dimensions significantly alter gravity's behavior at small scales, black holes could potentially form at the Large Hadron Collider. Despite the theoretical possibility, there is no empirical evidence that such processes occur in nature, despite particles interacting at energies far higher than those achievable by the collider in cosmic ray collisions in Earth's atmosphere.